Hi guys, this is Mrs. Rooker. I'm going to be doing day 3 with you, which is basically just combining growth and decay. So what you learned in day 1 and what you learned in day 2. And the first little section is just identifying whether it's growth or decay. So identify the following functions as exponential growth or decay, and then state the growth or decay factor. So to determine if it's growth or decay, we have to look at the B value. So I guess a quick little review into what the B value is might be helpful. So remember, our equation for exponentials is A times B to the x minus h plus k, or minus h power plus k on the end. So that is our formula, where B is the base to the exponent. B is also known as your growth or decay factor. So that's your B value. I guess it should be a little b, I think. I don't actually remember if it was big B or little b. So B is your growth or decay factor. If the absolute value of B is greater than 1, you have growth. And if the absolute value of B is between 0 and 1, then it's decay. So what that means is if you have a fraction or decimal that is less than 1, you have decay. All right, so let's practice this. We're going to highlight the B value on all of them. So the B is the base. So in this case, it's 1.58. That is bigger than 1, which means this is growth. Oops. And then we're supposed to state the growth or decay factor. That's going to be B equals 1.58. That's what tells us if it's growth or decay. So we call it the growth factor. On the next one, our B value is 0.692. That is a decimal that's between 0 and 1, which means it is decay. And the decay factor is going to be 0.692. All right, next one, the base is 15. Since that is bigger than 1, it's growth. And the growth factor is 15. All right. If you want to pause the video and try the next few on your own, then you can unpause and see me put my answers down. All right, the B value is 1/6. That is a fraction that's between 0 and 1. So that means it is decay. And the decay factor is 1/6. All right, number 5 might trick some people because we have a fraction. A lot of times people see fractions and they think decay. But that fraction, 5/4, since the numerator is bigger than the denominator, that's actually bigger than 1. If you are unsure, you can type it into your calculator, 5 divided by 4, and you end up getting 1.25. That is clearly bigger than 1, so that's growth. And the growth factor is 5/4. All right, 6 is another tricky one. Remember, negative exponents do not mean negative numbers. Negative exponents mean fractions. So I want you to rewrite this. Instead of 8, we are going to flip the fraction, and it's going to become 1/8. Because 8 is the same as 8 over 1, to get rid of the negative exponent, you flip the fraction. So anytime you think a negative exponent, think flip the fraction. And then the negative exponent goes away. So really, our growth factor, it will be a decay factor, ends up being 1/8, not 8. So you want to get rid of any negative exponents first before determining if it's growth or decay. So that negative flipped it, meaning we have decay. and the B value, or the decay factor, is 1/8. Same idea on the next one. You might not be able to see on my screen, but there is a negative exponent there, which means we are going to need to flip this, and it will no longer be 1/2, it'll be 2/1, which is just 2. And then this exponent will end up being positive. Technically, it'll be positive x minus 1. I'm not going to get into that too much right now, but because we're getting rid of that negative, it's going to affect the negative there. But either way, the B value becomes 2, which means that this is growth. And the growth factor is 2. All right, last one in this section. This is the same as the fraction 1/4. So think of this as 1/4 to the negative x. We don't want a negative exponent, so we're going to switch that so it becomes 4/1 to the x. Oops, that was supposed to be x there. So the growth factor, since that's bigger than 1, is going to be 4. So it's always just the number right in front of the exponent, and if the exponent has a negative in the front, you need to flip the B value. Moving on. So the first thing we want to do is identify if it's growth or decay, and then graph the function. So we don't have anything funky, we don't have any negative exponents or anything, and this B value is bigger than 1, so this is growth. And then we're going to plug in our crucial points. First we'll plug in -1. Something raised to the negative exponent means it's going to flip the fraction. So it's no longer going to be 3, it's going to be 1/3. Now let's plug in 0. Oops, anything to the 0 power is just 1. And lastly, let's plug in 1. 3 to the first power is just 3. Then we graph all those points. -1 1/3 is just going to be kind of a rough estimate. That looks like about 1/3 of the way up. And then 0, 1. And then 1, 1, 2, 3. Remember, we have what is called an asymptote at the x-axis. So it's just a dotted line at the x-axis that we're not going to cross. And then we start drawing our curve along the asymptote and curve it upward. Do not cross the asymptote with your curve. All right, domain is how far left and right it goes. This arrow means it goes forever left. That arrow means it goes forever right, which means all real numbers, or ARN, however you want to write it, for the domain. Range is how high up and down it goes. Well, this arrow here says it's going forever up. But there's an asymptote that it's never going to touch and it's never going to cross. So it never goes below 0 since the asymptote's here at 0. So the range is going to be that y is greater than 0 because it's above 0. And it's not going to be equal to because it's never going to touch the asymptote. All right, next one, I see that I have a negative exponent, which is really important for me to notice. I need to get rid of the negative exponent. So I'm going to flip this. Instead of 4, it's going to become 1/4, and the exponent becomes positive. Since that's a fraction between 0 and 1, this is going to be decay, which means my graph is going to start upward and kind of slant downward. All right, so let's pick some points. If we plug in a -1 here, 1/4 to the -1 is going to flip it again. So it's now going to become positive 4. If we plug 0 in, anything to the 0 power is 1. And plug 1 in, anything to the first power is just itself. So it's just going to be 1/4. Graph those points. -1, 4. 0, 1. And 1, 1/4 is going to be really small. There should be an asymptote at 0, and then we just curve. Remember, this should not cross the asymptote. Domain, how far left and right does it go? Should go forever, so all real numbers. Range is how high up and down it goes. It still goes forever up. It still does not go below 0. So your range is going to be y is greater than 0. All right, lastly, we are going to identify what type of graph we have here, and I'm going to kind of talk about a few little tricks to identify the type of function. So we're going to be choosing between linear functions, quadratic functions, and exponential functions, because those are the types of functions we've done so far this year. You might also see an absolute value. Remember, that's a V shape. So linear looks like a straight line. So straight line, no curve. Quadratic is a U shape. Exponential is like this. That's exponential growth, or exponential decay looks like that. And then absolute value is a V. So one way to figure out what type of graph we have is to plot the points, and you may or may not be able to determine what type of graph you have from that method. So let's do that with number 11. 1, 2 is our first point. 1, 2. Our next point is 2, 5. 1, 2, 1, 2, 3, 4, 5. Then our next point is 3, 8. I'm a little bit off the graph, and I'm continuing. I mean, the rest of them are going to be way off the graph, so I'm not going to continue graphing them, but it looks to me like it's fairly straight. It doesn't seem to be curving up or curving down, so it looks pretty linear. And what I'm going to do next is another way to confirm that it's linear is I look at the second row and I count the difference, meaning I count how far it's going up between these two. So from 2 to 5, that's going up 3. And then from 5 to 8, it's also going up 3. And then from 8 to 11, that also goes up by 3. And then by 3 again. So if the difference is constant, it's going to be linear. So things to remember about linear. It's a straight line, and the amount that it goes up, or the difference, is constant. I forgot to mention that this is what we call the first difference. Since the first time we took the difference between the two numbers, it was constant, it was linear. So now let's graph the next one and see what we've got going on here. So we've got 1, 0. 1, 0, 2, 3, then 3, 8, and then it's going to be way too high for me to graph. So I kind of notice on this one that it doesn't appear to be super straight. It's curving upward a little, which could mean that it's either exponential or quadratic. Those both have curves. So those are the hardest ones to choose between, is quadratic and exponential. So that's when we're going to look at the differences. This goes up by 3, that goes up by 5, that goes up by 7, that goes up by 9. And then I notice a pattern when I look at these. Those are each only going up, or those are each going up by 2. So the first difference went up by the first difference isn't constant. Those aren't the same numbers. But if I take a second difference, that goes up by 2, that goes up by 2, and that goes up by 2. If the second difference is constant, meaning the same, then we know it is quadratic. And quadratic looks like this, but it looks like we're only seeing one side of it. It's probably going to curve this way on the other side. We just don't see that yet. So quadratic is a U shape, but we're only seeing part of the U there. All right, now let's do our next one. We'll graph this. We see the points 1, 0, 2, 2, 3, 6, 2, 3, 4, 5, 6, and then 4, 14 way off the graph. So again, it appears to be curving, so it's either quadratic or exponential. I've looked to see if we see any kind of pattern here, and I don't notice a pattern, so I'm going to check the differences again. So this is 2, this goes up by 4, this goes up by 8, that's interesting. That goes up by 16, and if you don't know how much it goes up, you just subtract the smaller one from the bigger one, and it'll give you the difference. Remember, difference means subtract. So if I were to try and take a second difference, it's not going up by the same amount each time. I notice a pattern here though. It looks like it's doubling. If it's doubling, tripling, if it looks like you have to multiply the first one by something to get the second one, that's going to be exponential. And based on this picture, it appears to be exponential growth, not decay, because it's going, sorry, my pen glitched out. It's going upward. All right, that is it. So linear is going to make a straight line, so that should be easy to determine. Quadratic is going to be curved, and to find it, you find the second difference, and if those are the same, then it's quadratic. For exponential, if the second difference isn't the same, but you notice that it's doubling or tripling or something like that, then it is exponential. And that is it for today. Have a good one, guys.